Right, let's start with Derrida's theorem. Prove that d by dx of cos inverse of x is minus 1 upon square root of 1 minus x square. So let us assume that y is equal to cos inverse of x. Therefore, I can say that x is equal to cos y. If I take the cos on the other side, let's try to see the minimum and maximum values of cos function. Cos 0, 90, 180, 270, 360. Cos of 0 is 1, 0, minus 1, 0, 1. Right? Now, that means the maximum and minimum value that x can have is minus 1 and 1. The minimum value of x is at 180 degree and the maximum value of x is at 270 degree. The minimum value of x is at 180 degree and the maximum value is at 0 degrees. So I can say that y is greater than 0 and less than 180 degree. Y is greater than 0 and less than 180 degree. Now let's continue with where we had left. X is equal to cos y. Differentiate with respect to y. So you will get d by dy of x is d by dy of cos y. So you will get dx by dy. D by dy of cos y is minus sin y. So you can say that dx by dy is minus sin theta. We know from identities that sin theta is square root of 1 minus cos square theta. This can be written as plus minus square root of 1 minus cos square y. Dx by dy is minus plus minus square root of 1 minus cos y. Right in the beginning of the sum we had assumed as x. So 1 minus x square. Right? Now I can say that as y is greater than 0 and less than 180, therefore I can say either y is in first quadrant or y is in second quadrant. If y is in first quadrant, then cos y is positive. If y is in first quadrant, then cos y is positive. Sin y. We have d by dx by dy is sin y. So you will get sin y is positive. You will have sin y as positive if y is in second quadrant. Then also sin y is positive because in second quadrant sin ratio is positive. So whether it is in first quadrant or second quadrant, sin function is going to be positive. Now let's see this. That means out of this positive negative sign of square root that you have, you can safely eliminate the negative sign because cos function will not be negative. Sin function will not be negative. Therefore you can say that dx by dy is minus positive square root of 1 minus x square. So you can say that dx by dy is minus 1 minus square root of 1 minus x square. Reciprocate this. If I reciprocate this, I will get dy by dx is minus 1 upon square root of 1 minus x square. Right? Now, therefore, you can substitute this value of y. You can therefore say that d by dx of cos inverse of x is minus 1 upon square root of 1 minus x square. Finally, get this? Where you could also say that x has to be greater than less than, where x has to be greater than minus 1 and less than 1. Why not the equal to sign? Because I don't want the denominator to be 0, and y is greater than 0 and less than 180 degree. Fine, do we get this thing clear? Let's move on ahead, guys. prove that d dy dx of tan inverse of x is 1 upon 1 plus x square. Let's see the sum. You will say let x be equal to, let y be equal to tan inverse of x. If y is equal to tan inverse of x, then I can say that x is equal to tan y. Now, let's look at the tan function, guys. 0, 90, 180, 270, 360. Tan of 0 is 0. Tan 90 is infinity. Tan 180 is 0. Tan 270 is minus infinity. Tan 360 is 0. That means tan function could be anything which could be a real number. So I can say where x should belong to a real number, any real number up to infinity, and y, it is maximum and minimum at 90 and 270. 270 can be written as minus 90. 270 can be written as minus 90. Now let's see this. X is equal to tan y. Differentiate with respect to y. So you will get dy dy of x is dy dy of tan y. So you will get dx by dy. Dy dy of tan y is nothing but sec square y. Dx by dy. Sec square theta by identities is nothing but 1 plus tan square theta. But we have already assumed tan y to be x. So dx by dy is 1 plus x square. Since there is no plus minus sign, I need not check in which quadrant they are. I can just reciprocate and get the answer. Therefore, I can say that dy dx of y is 1 upon 1 plus x square. Therefore, dy dx of tan inverse of x is 1 upon 1 plus x square. Simple, easy sum. Fine, do we get this thing clear? Right? Let's move on to the next sum, guys. Prove that dy dx of cot inverse of x is minus 1 upon 1 plus x square. Right? You will say that let y be equal to cot inverse of x. Therefore, I can say x is equal to cot y. I take cot inverse on the other side. We've been doing this in all the previous sums. Now, again you can say that here x is going to have same values as that of, see, I'll show you. Cot 0, I'll just show you with tan so that you understand. Tan 0, 90, 180, 270, 360. This is nothing but tan of 0 is 0, infinity, 0, minus infinity, 0. Cot is 1 upon tan, and we know that 1 upon 0 is infinity, so this will be infinity, 0, minus infinity, 0, infinity. Again, that means for cot function also the minimum and maximum values are infinity. The minimum and maximum values are infinity, therefore I can say x belongs to a real number, right? Where y belongs to, it has to be greater than 180 and less than 0, right? Now, as x is equal to cot y, as x is equal to cot y, differentiate with respect to y. So you will get dy dy of x is dy dy of cot y, right? dy dy of cot y, dx by dy. dy dy of cot y is nothing but minus cosec square y, minus cosec square y. Here I can use the identities. If I use identities, I'll get dx by dy. Cosec square theta is nothing but 1 plus cot square theta, right? So you will get dx by dy is minus 1 plus cot square y. Cot y we have already assumed as x. Since there is no square root sign, I need not check which quadrant they are. Just reciprocate this. So I'll get dy by dx is minus 1 upon 1 plus x square. Right? Straightforward sum. Fine, do we understand this? Let's move on to the next sum, guys. D by dx, prove that d by dx of sec inverse of x is 1 upon modulus of x square root of x square minus 1. Fine. Right? You will say, let us assume that y is equal to sec inverse of x. Therefore, I can say that x is equal to sec y. Now the sec function and the cos function have same limits. The sec function and the cos functions have same limits. That means I can say x can have maximum and minimum value of -1 and 1, where y will be same values that you had for cos function. Guys, just recap the values that you had for cos function. That is going to be 0 and 180 degree. Now x is equal to sec y. Differentiate with respect to y, so you will get d by dy of x is d by dy of sec y. So you will get dx by dy. D by dy of sec y is nothing but sec y tan y. Dx by dy is nothing but sec y into tan y. Now we know that sec square theta is 1 plus tan square theta. Therefore tan square theta can be written as plus minus square root of sec square theta minus 1. Right? Fine, do we get this thing clear? So you will have dx by dy is nothing but plus minus sec y square root of x square y minus 1, right? Now as y is greater than pi and less than 0, therefore y can either be in first quadrant or second quadrant. Now if y is in first quadrant, then sec y is positive, tan y is positive, therefore sec y into tan y is positive. If y is in second quadrant, then sec y is negative, tan y is negative, therefore sec y into tan y is positive. Since both are negative, product of two negative numbers is positive. This implies that irrespective of what the value of sec y and tan y is, irrespective of whether they are positive or negative, my final answer will always be positive. And this in maths is represented with modulus function. So therefore I can say that dx by dy, the answer is always going to be positive. So out of the positive negative sign, I will eliminate the negative sign, put a modulus sign, and I will write this as sec y square root of sec square y minus 1. But right in the beginning of the sum we had assumed the value of sec y to be x. So I can substitute this here. So I will get dx by dy is modulus of x square root of x square minus 1. Let's complete the sum here. Reciprocate this. dy by dx is nothing but 1 upon modulus of x square root of x square minus 1, where we have to make sure that the denominator is not 0. The denominator will not be 0 when x is greater than minus 1 and less than 1, and y is greater than 0 and less than 180. Fine, do we get this thing clear? Can you just go through the sum once again, please? Okay, I hope by now everybody is very clear with the sum. Everyone's seen the sum very clearly, everyone's very clear with the sum. Right, so now that we are very clear with this sum, we can move on with the next sum. Prove that d by dx of cosec inverse of x is minus 1 upon modulus of x square root of x square minus 1. Same method that we've been doing in the last sum. That's the reason I asked you to review the last sum very carefully, because we'll be using the same thing here. Let y be equal to cosec inverse of x. Therefore, x is equal to cosec y. I'm taking the inverse on the other side. Now, cos function and sine function has the same limit. Cos function and sine function has the same limit. Therefore, I can say x is greater than 1 and less than minus 1, and y is greater than minus pi by 2 and less than pi by 2. Fine? Same function that you had, same value, same limits that you had for sine function. Now, you will say as x is equal to cosec y, differentiate with respect to y. So you will get d by dy of x is d by dy of cosec y. So you will get dx by dy. d by dy of cosec y is minus cosec y cot y. Fine. This can be written as dx by dy is minus cosec y into, now we have an identity which says that cosec square theta is nothing but 1 plus cot square theta. Therefore, cot square theta can be written, or cot theta can be written as plus minus square root of cosec square y minus 1. Right? So this can be written as dx by dy is minus plus minus cosec y into square root of cosec square y minus 1. Now, as y is greater than minus pi by 2, that is 270, and less than pi by 2, therefore either y is in first quadrant or y is in fourth quadrant. Right? If y is in first quadrant, then cosec y is positive, cot y is positive, therefore cosec y into cot y is positive. If y is in the fourth quadrant, then cosec y is negative. Only cos function is positive in the fourth quadrant, guys. Cot y is negative. Since both the values are negative, therefore I can say that cosec y into cot y is positive. Minus into minus is plus. That means in the square root where we had plus minus, we know that irrespective of whether the value is positive or negative, I will always get a positive value. Therefore, I can say that dx by dy is minus cosec y into square root of cosec square y minus 1. But right in the beginning of the sum, we had assumed cosec y to be x. So I can substitute this here. So in which case I will get dx by dy is minus x square root of x square minus 1. Let's complete the sum here. Right? If I reciprocate, I will get dy by dx is minus 1 upon modulus of x square root of x square minus 1. I have to make sure that the denominator is not 0, so x is greater than x is greater than minus 1 and less than 1, and y is greater than minus pi by 2 and less than pi by 2. That finishes this theorem, and that finishes all the theorems that you need to know in derivatives. Let us stop here for the day. Thank you very much.